Now it's fine.
Yes, I think it looks good.
Okay, sir.
Okay, so good morning, everyone, and welcome to this lecture. Newton's laws of motion we are dealing with, and in today's class, we'll continue what we were doing in the previous class. And in the previous class, we had discussed the concept of equilibrium. Can you tell me what do you mean by equilibrium? Fatafat, we don't have time. What do you mean by equilibrium? Hmm, forgotten. If you have to look back, turning over the pages when you come to the class, that means you have not studied what we had done in the previous class. That is a very bad sign. Remember, if you think that just coming to the class and sitting there for 1 hour, 2 hour, whatever time, we are going to create IITians out of you, that is impossible. Beta, if you don't study at home, 1 hour of class is going to do no difference in your life. Do we understand this? Please, before coming to the class, please go through what we had done in the previous class. And this is what we had done in the previous class. We have seen that force is zero. Whenever the net force acting on the body is zero, we say that the body is in equilibrium. That means either the body is at rest or it is moving with uniform velocity. That is what we meant by equilibrium. Do we understand it now?
Yes, sir.
Equilibrium means that the body is at rest
Rest or uniform velocity.
or it is probably moving with a uniform velocity. I hope you remember it now.
Yes, sir.
Okay. A body moving with uniform velocity or it at rest is what we say a body in equilibrium, and the first category of questions will be based on equilibrium. How will you solve this question of equilibrium? So we'll write steps of solving questions of body in equilibrium. And what are these steps? What will be the first step? What will be the first step of solving problems in equilibrium? Yes, the first
We
step
make a
would be to
diagram.
draw a sketch of the problem. Yes or no?
Yes, sir.
What would be the second step? What would be the second step? How do you do it? So I'll just tell you all the steps and you write it, and we will then try to follow these steps and understand how it is done. So step number one, as you can see, is to draw a sketch of the diagram. That sketch you don't have to draw because that sketch is already there on the question. The next step would be to isolate every single body and draw the free body diagrams. Free body diagram, that is important. I told you to draw free body diagrams in the last class. And we have to label all the forces which are acting on the body, find out all the forces which are acting on the body. Step number 3 will we have to choose a convenient coordinate system. Normally we take horizontal as x and vertical as y. That is the coordinate system that we choose, but sometimes we might have to choose a different coordinate system. Depending on the question, we can choose the coordinate system. Now when you choose the coordinate system, you have to resolve all the forces along the x and y direction. Once you have the coordinate system, not all the forces would be acting along the chosen coordinate system. So you'll have to resolve them along the chosen coordinate system. Then you apply net force on the x-axis 0, or you can say whatever forces are on the positive x-axis, the same forces must be there on the negative x, so they must equate. Similarly, whatever forces are there on the positive y, they must be equal to the forces on the negative y. And this is how, after this step, you will get certain equations, you will get certain unknowns, solve for that equations and the unknowns, and you will get your answers. Do we understand this?
Yes, sir.
This is how we have to solve each and every problem that comes in equilibrium, or for that matter, whenever the body is moving with uniform velocity, also same thing has to be applied. When the body is having some acceleration, only the last step will change. In the last step, when we are equating all the forces to 0, there will not be all forces equal to 0. Maybe forces along y-axis would be 0, but there will be force along x-axis. Maybe there will be force along y-axis and no force along x-axis, or there may be force along x-axis as well as net force along y-axis. So the only thing that will change when we do questions which are not questions of equilibrium, then only the last step will change. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, so I hope you have written down the steps. You don't have to write each and everything. You just have to write the important points in whatever language that you feel comfortable. Now we are going to apply whatever we have seen in a diagram, in a question. And this is the question that we are going to apply it. I have drawn. I hope you have written the steps. Yes or no?
Done, sir.
I have drawn a body of mass m, and this body of mass m is attached to a string. You have to tell me what is the tension in the string. The body is in equilibrium. Right now it is not moving, so it is at rest. The body is in equilibrium. A body of mass m is hanging by a string. What is the tension in the string? The body is definitely at rest. Don't worry about that. The body is at rest. Can you tell me what is the tension in the string? I'll give you a 2 minutes to solve this. Do it fast. Yes, do we have an answer, my dear friends?
Tension is empty.
Tension is mg. So how did you do it? You first draw a sketch. Sketch is already there. Then you draw then you isolate the body. I'm not going to isolate it. I'm just going to draw it here because it's very simple. Then you draw all the forces acting on the body. There's only one body that I see. The force on that body is gravitational force mg,
Gravitational force.
and then there is string pulling it. Remember, string can only pull it. It cannot push it. So string will pull it like this. Yes or no? So I've drawn all the forces. Then I will assume one x-axis and one y-axis. What is the best way to take x-axis or y-axis here? I can take the vertical as y-axis and I can take horizontal as the x-axis. Yes or no?
Yes, sir.
So this is my coordinate system. I can see there is no force along x-axis, so x-axis goes away. There is only force acting along the y-axis. The body is in equilibrium, so whatever force is on the top, in the upward direction, same force has to be in the downward direction. Upward direction there is T, downward direction there is mg. So along y-axis, The equation, there's only one equation that is possible, and that is T equates mg, and that is the answer for this one. Do we understand this? Yes or no? No, yes.
Yes, sir.
Pakka? Anyone understand this? Can I give you the next question?
Yes, sir.
Remember, this is what you got to do in every question that appears, no matter what. Question is simple and you have to solve it in simple sense. Now comes question number 2 on your screens right now. We have a box or a body of mass 30 root 3. There is a reason why root 3 is given. Is kept by 2 strings. Do you see the 2 strings? Do you see the 2 strings? First string is AO. You have to find the tension in both the strings. You can call the tension in this string as T1. You can call the tension in this string as T2. You have to tell me the value of T1 and T2, and your time starts now. Yes, my dear friends, do we have answers? T1 and T2. Yes or no? No, yes. No? Shall I do it?
Both sir, we are doing.
You are trying? Okay. 2 minutes. Yes, my dear friends, do you have an answer? No?
T1 is 10 and T2 is 20.
Okay, that looks correct. So how do I do it? First of all, I draw a sketch. I don't have to draw a sketch. The sketch is already there. I isolate the body. There is no need to isolate because there is only one body. What will I isolate? I move on to the third step. I draw the free body diagram. Yes or no? I draw the force.
So you're not audible.
I'm not audible. You sure I'm not audible?
Sir, it's okay. It's fine now, sir.
I think my mic is working correctly. I mean, am I audible?
Yes, sir.
Okay. So weight of this body is 10 root 3 Newton. It is acting downwards. Yes or no? Do we understand this?
Yes, sir.
Tension T. This pulley, this rope is going to pull it like this. T1. Yes or no?
Yes, sir.
This rope will pull it like this. T2. Yes or no?
Yes, sir.
Now I can draw a coordinate system. Coordinate system I can choose. So let me take this as my x-axis and this as my y. Sorry, this as my x-axis and this as my y-axis. Do we understand my coordinate system?
Yes, sir.
Now what you can see here in this coordinate system is this T1 and this 10 root 3 are okay because they are along x and y. But you see this T2 not going in x and y. So what will I do? I will resolve this T2. Yes or no? I will resolve this T2 into two components. What are the two components? The first component is like this and the second component is like this. Yes or no?
Yes.
You know how much is this component? This angle is 60 degrees. So this angle will also be 60 degrees. Yes or no? So I will have this as T2 cos 60 and this one as T2 sine 60. Do we understand this? Yes or no?
Yes, sir.
We just now need to equate the x component, the y component. What do you see along x-axis? Tell me. What do you see along x-axis? T1 is along negative x and T2 is along positive x. So T1 becomes equal to T2 cos 60. Cos 60 is 1 by 2. Yes or no?
Yes, sir.
What do you see along y-axis? Along y-axis, T2 sine 60 is in the upward direction. Sine 60 is root 3 by 2. So root 3 by 2 T2 is simply equal to 10 root 3. From there, you can get T2 as 20 and T1 as 10. Do we understand this? Yes or no?
Yes, sir.
Everyone was able to do this question?
Yes.
Can I move on to the next one?
Yes.
Here comes the next one. And it is as simple as it gets. Question number 3. Question number 3 for you. Block A and B are hung on a, they are not one pulley, remember there are two pulleys. Let us say the mass of block 1, A is M1 and the mass of block B is M2. You have to find the relation between M1 and M2. Remember the system is in
Equilibrium.
equilibrium and you have 2 minutes to do this. You got the answer, my dear friends? Yes or no? Okay. Let us solve this step by step. Draw a sketch. Sketch is already there. You have to isolate the graph. I don't want to isolate. I can draw it here. Let us take body number A. What are the what are the forces acting on body number A? One is the weight m1g. Do we understand this? Then there is tension T1 in the string because there are two strings. Do you see two strings? One is the string on one pulley, the other one is the string on the other pulley. T1, 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 and T1. Do we understand how I've drawn? Tension in one string will always remain same, yes or no? Now, as you can see here, my bacha, T1 and T1 are acting in the upward direction. Now, let us draw the free body diagram of this block. For this block, it will be simply M2G here, yes or no? I can't hear you. This is M2G in the downward direction, yes or no?
Yes, sir.
Then there will be T2, which will be acting in the upward direction for this block, yes or no?
Yes, sir.
Now, if I draw the free body diagram of this pulley, remember pulley is ideal. On this pulley, I have T1 and T1 in the upward direction. Do we see this? And one T2 in the downward direction. Do we see this?
Yes, sir.
Remember, the pulley is always ideal. So the net force acting on the pulley must be 0. That means T1 and T1 in the upward direction should be equal to T2 in the downward direction. Yes or no?
Yes, sir.
So I can write this T2 as 2 times T1. Yes or no?
Yes, sir.
So this T2 becomes equal to 2 times T1. From now onwards, I will not write them T1 or T2. I will just write T. For example, I will write this as T, 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 T. Everything I'll cut. And since I understand, I will write this as T, 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 T. And this one would be 2T. Do we understand this?
Yes, sir.
So now I can write, look at this graph. This is the free body diagram of body 1, the green one, and the pink one is the free body diagram of body 2. Do we understand this?
Yes, sir.
From the green one, I can write, T is equal to M1G, yes or no?
Yes, sir.
From the pink one, I can write 2T is equal to M2G, yes or no?
Yes, sir.
From these two, I know you are good enough to solve and get the answer. Yes or no?
Yes.
Everyone got this? Chalo. That means we are doing okay here. Can you move on to the next question?
Yes, sir.
The next example is this one. Now remember, sometimes we may not be using horizontal and vertical as our reference axis. Sometimes we might have to use other convenient axis as our x and y axis. I told you that, yes or no?
Yes.
So this is an example in which you might have to do that. So let us discuss this because there will be a lot of questions that will be coming in this type. Example number 3, a box of mass m rests on a smooth slope with the help of a thread as shown in the figure. The thread is parallel to the inclined plane. Draw the free body diagram. Find the tension in the thread. The thread is replaced by a spring or spring constant. We have not discussed spring. We will discuss spring in this question only since the question has come. So you can do, I think, part number A and part number B. Yes or no? So do part number A and part number B, and then we will try part number 3. We'll be introducing the third type of force, spring force. 2 minutes you have. Could you do this? Or you want more time? Shall I do it for you? Give you 1 more minute. Okay. Shall I do it for you now? There's only one body for which you have to draw the free body diagram, and that is this block of mass M. Yes or no?
Yes, sir.
So I draw the free body diagram of this block. This weight mg goes downwards. Yes or no?
Yes, sir.
Then there is normal reaction also coming N, which
Yes.
will be perpendicular. Yes or no?
Yes, sir.
Then there would be tension T, which would be like this. Yes or no?
Yes, sir.
Do we understand this? Now, how should we choose x and y axis for this particular case? Tell me, how should I choose x and y axis for this particular case? The best way to choose x and y axis would be if I take this axis which is perpendicular as my y and this axis which is parallel to the plane as my x axis. Yes or no, my dear friends?
Yes, sir.
Do we understand this? Now, as soon as this is done, we understand that this normal and this t don't have a problem because they are along x or y, but this weight mg has a problem because this weight mg is going in the downward direction. Do we understand this? So we'll have to resolve this mg into two components. Do we understand this?
Yes, sir.
And we resolve it like this. One component always comes here and the other component always goes here. You don't have to do it again. You just remember that this component is mg cos theta and this component is mg sin theta always. Now you can make your equation along x-axis and y-axis. This is your x-axis and this is your y-axis. What is your equation along x-axis? Remember, the body is in equilibrium. Yes.
Decide.
T is equal to mg sin theta. Do we understand this?
Yes, sir.
And what is the equation along y-axis?
mg cos theta. T
Normal reaction
is equal
N
to
is equal to mg cos theta. Do we all understand this? Now the next part of the question says that what will happen if you replace this string by a spring. Now as soon as this spring comes, we must understand what is the force in the spring. So we'll just write the next heading, spring force. Do you know spring force? How much is the spring force? Do we know how much is the spring force, bacha? Please tell me fatafat.
minus k.
Minus only indicating the direction. So if I have a spring Every spring has something which is known as the force constant. Yes or no? We understand this?
Yes, sir.
Every spring has something which is known as the natural length of the spring, L naught. Do we know this? Yes or no? When the spring in its natural state, natural length, there is no force in the spring. Do we understand this? Yes or no? If I now extend this spring by X, this is an extension, what will happen is spring will try to pull it back. Yes or no? So in that case, it will try to pull it. The force will be equal to Kx.
Okay.
If it is, instead of extension, it is compressed by a distance of X, it will now push it. Do we understand this with the same force Kx? Yes or no? So spring force is Kx. We can call it as minus Kx if you write it in the vector form, because it is always opposite to the direction of X. If X is extension, the spring will try to pull it. If X is compression, spring will try to push it. So spring can pull as well as it can push. So that is how a spring is different from a string, because a string cannot push. Do we understand this? So whenever we talk about spring force, we must always think about K into X. Looking at whether the spring is extended or the spring is compressed, we can draw it as a push or a pull. Now we get back to the same problem. Now we get back to the same problem and try to solve it with this being a spring and not a string. Have you solved it? Yes or no? Okay, so I will now make it into a spring. Now it becomes a spring and its spring constant is, let us say, K. Now when I put it like this, will it extend the spring or will it compress the spring? When I put it like this, will it extend the spring or will it compress the spring, this block? Will the spring be compressed or will the spring be extended? This is extended and this is compressed. It will be extended. The spring will try to, the block will try to extend the spring. Yes or no? Now let me again draw the free body diagram of the block. This is mg. This is normal reaction N. Do we understand this?
Yes, sir.
Then, since the spring is extended, it will try to pull it like this. Yes or no? I can call this as Fs. Fs stand for the force in the spring. Do we understand this? Then again, I am supposed to draw my coordinate axis. My coordinate axis will look like this. This will be my y-axis. This will be my x-axis. If I look at this normal reaction and Fs, they are along x and y direction. The only thing that is not there is mg, so I can resolve mg into two components. I've already told you this component is always equal to mg sine theta, yes or no? And this component is always equal to mg cos theta. Now I can write equation along x-axis and y-axis. What is the equation along x-axis? mg sine theta is equal to Fs, spring force, and that will be equal to K into X. Yes or no?
Yes, sir.
From here, you can find out the value of X. The value of X will be mg sine theta divided by K. The other equation remains same. N is equal to mg cos theta. All of us understand this? Yes or no?
Yes, sir.
Everyone got this answer? Can I give you another one?
Yes, sir.
Okay. So let us see if you can do this one. This question is a standard question, has come many a time in different ways. Let us see. If you can solve this one. And the question comes here right now. Question number 3 or 4, whatever it is. A 70 kg man standing on a weighing machine. You can see this weighing machine?
Yes, sir.
This one. A 70 kg man standing on the weighing machine in a 50 kg lift pulls on the rope, which suppose the lift as shown in the figure. Find the force with which the man should pull on the rope to keep the lift stationary and the weight of the man as shown by the weighing machine. So you have to find out two things: the force with which the man should pull and the weight of the man on the weighing machine. Whenever you are weighing your weight on the weighing machine, what does the weighing machine tell you? If this is the weighing machine, wrong color. If this is the weighing machine and you are standing on the top of weighing machine, what reading does the weighing machine give you?
Wait.
If I draw the free body diagram of the man, the weight of the man is going downwards. The normal reaction from the weighing machine is going upwards. Which value does the weighing machine tell us?
MG, sir.
Which value does the weighing machine tell us? It tells us the value, it tells us the force with which the man is pushing down the weighing machine. So it tells us the value of N. It does not tell you the value of mg. But since there is no other force, this N becomes equal to mg and therefore it tells you its weight. But it will only tell you its weight in this condition. If there are other forces acting on it, it will never tell you your weight, it will only tell you your normal reaction, the force with which you are pushing the weighing machine. Do we understand this? Yes or no?
Yes, sir.
That is the note that you will write. What will you write in a note? Weighing machine does not tell us weight. A weighing machine tells us the force with which we are pushing the weighing machine. Do we understand this? Having said that, this is the question, and I hope to get an answer from your end. Anyone got the answer? Try. Trial is important. Answers are not. You might get the answer, you might not get the answer. That is not important. What is important is that you are trying. Should I solve it for you? You have to draw the free body diagram of two things. One is the lift and the other one is the man and the weighing machine, whatever you call it. Okay. Now looking at the lift, if I draw the lift here, if this is the lift, what are the forces acting on the lift? What are the forces acting on the lift? One is the weight of the lift, which is 50 G, yeah, 500 downwards, yes or no? The first thing about the lift is the weight of the lift, 500 downwards, yes or no? Yes. Then there is something which is holding the lift up, which is this pulley, yes or no? And you can easily find out the tension in this pulley. The tension in this pulley will be 2T. If I take this as T, yes or no? Do we understand this, my dear friends? Yes or no? Now, apart from this, is there any other force acting on the lift? The man and the weighing machine, and weighing machine does not have any weight. The man is pushing the weighing machine and the weighing machine is putting the lift. Yes or no? It is pushing it downward. So let us call this normal reaction as N. Now this N is the reading of the weighing machine. Do we understand this? This is the force with which man is pushing the weighing machine. This is the force with which weighing machine is pushing the man.
Yes.
This is also the force with which lift is pushing the man and the weighing machine. This is also the end which man and weighing machine is pushing the lift. Do we understand this?
Yes, sir.
Now, if you this is the free body diagram of the lift, let us now make the free body diagram of the man, and I'm drawing the man like this. What are the forces acting on the man? One is the weight of the man, which is 700 Newton downwards, yes or no?
Yes, sir.
One is the weighing machine pushing it upwards, normal reaction, and yes or no?
Yes, sir.
One is the tension T in the string, yes or no? This is the green one, which is the free body diagram of lift. This is the pink one, which is the free body diagram of this gentleman, man. What do you get from this green equation? $500 downwards plus N downwards is equal to 2T. Do we get this?
Yes, sir.
What do we get from this pink gentleman? N plus T is equal to 700 newtons, yes or no?
Yes.
I think you are good enough to solve it from here. You can tell me the value of T and you can tell me the value of N. Tell me fatafat. What is the value of T and what is the value of N? I think T would be coming as 400 newtons and N would be coming normal reaction, or the reading in the weighing machine would be coming as 300 newtons. Do we get this answer?
Yes.
Is the concept clear to everyone what we are doing? We are doing the same thing, drawing the sketch, isolating the bodies, drawing the free body diagrams, finding out convenient axes, finding out the forces, resolving the forces, and then just equating them along x and y. Do we understand this, yes or no?
Yes, sir.
Well, then I will wind up this class. I'll send you some sheets of some questions that you can practice at home. I'll send you that sheet so you can try questions on that sheet. And I'll see you in the next class, which is tomorrow. If you have any doubts, you can always come up to me. Else it's a wrap from my end. Take care and have a nice day ahead.